Okay, the question is, a person 40 kg is managing to be at rest between two vertical walls by pressing one wall A by his hand and feet, and the other wall B by his back. Okay, assume that friction coefficient between the body and the wall is 0.8 and that limiting friction acts at all contacts. So limiting friction is acting at back and hand and feet. Okay, show that person pushes the two walls with equal force. So first is, what are the forces, what are the different forces acting on the person? So free body diagram. So first we will see mg is acting. Okay, then there will be a normal force from here and normal force from here. So n1 and n2, and there will be friction force. So friction from here, suppose F1 and then F2 from this side. Okay, what are the different forces? So mg, then we have n1, then we have n2, then we have friction F1, then we have friction F2. Okay, so these are the forces. Now, since the person is not moving horizontally, so N1 will be equal to N2. So N1 will be N2. Why? Because person is in equilibrium horizontally. Okay, so these are the two things. Now, F1 plus F2 will also be mg. So F1 plus F2 will also be mg. So why this is there? Because person is in equilibrium in vertical also. Vertical equilibrium. Vertical equilibrium. Okay, both the direction equilibrium is there. Okay, so F1, F2. So F1 is how much? F1, F2. These two will be N1, since N1 equal to N2. So that first part we have shown. Show that the person pushes two walls with equal force. So that first part is proved. That is part A. And find the normal force exerted by either wall on the person. So how much will be the normal force exerted? If he has to act the limiting friction, we have to consider the limiting friction case. Okay. So if you have to consider limiting friction, means we will consider the maximum value of friction. That is written. We will write mu times N1 plus mu times N2. N1 and N2 are same. So we can write it mu N1 plus mu N1 equal to mg, or we can solve it 2 mu N1 equal to mg, or N1 is how much? Mg by 2 mu. Mg 40 kg into 10 divided by 2 into 0.8. Okay, so it will be 500 by 250 Newton. So normal N1 is coming 250, so N2 will also be 250 Newton. So both the normal forces exerted by man is 250 Newton. So in this way we can solve. So he has to apply at least this much normal force. Only then he will be able to remain between the walls. Otherwise he will slip down.